So I'm back. Thanks for having me back again. The topic is Wi-Fi client data and the cloud. Once again, there's my Twitter address. Quick little scientific poll. How many people here, raise your hand, are following me on Twitter? Okay, now how many people are following Keith Parsons? Okay, I thought so. Keith has like, what, 12,000 followers, something like, he's like the Kim Kardashian of, my main topic is, really it's two topics, is cloud, and I want to talk about the maximum client capabilities of clients, and I'm going to try to tie them together. But I have one other little thing I want to talk about, thanks to this gentleman right here. PCF really did? Or, how many of you guys had to learn PCF back in the early days of CWMP? So, I can't believe it. So where are the packet captures, my friend? Because I got to tell you, if no packet captures, it did not happen. Okay? And if this alleged PCF actually exists, please don't tell Devin Aiken, okay? Because he will gloat for years about how he was right to teach us PCF. So please don't tell him. Okay, now, so 2 weeks ago, I did a presentation at CWMP about cloud networking and how if you're not in the cloud, resistance is futile, you will be in the cloud. You probably already are in the cloud. If you're using Office 365 or Salesforce, you're in the cloud. And the networking industry is all going to the cloud, whether you want to or not. And it's actually a good thing. Now, I am not going to do the same full presentation that I did 2 weeks ago, but I am going to touch on a few highlights about cloud networking. And all cloud networking is that your infrastructure and networking capabilities are in somebody else's data center, like Amazon's or Google's. It doesn't exist in your data center. And it's basically provided as your networking monitoring and management is provided as a third-party service. It's usually a subscription-based service. Some of you that are already familiar with AeroHive knew it as Hive Manager. Hive Manager has been rebranded. So the cloud formerly known as Hive Manager is now known as Extreme Cloud IQ. I just wanted to give you a quick little overview of how how this kind of scales for us globally. One of the cool things about a third generation cloud, or even some of the earlier generations of cloud, if done properly, it can be scaled globally. We actually have data centers all over the world, but it's not our data centers. It's either in Amazon or Google data centers, and it has a infrastructure that's kind of built like this. We call the global data center and the regional data center. And they have the global data center and regional data centers have different purposes. To be very fast on this, the global data center manages customer and admin user accounts. So basically the logins, the signing in, and it's basically the landing page when you sign in to log in. And it also manages firmware updates for access points and switches and other networking devices that are managed in the cloud. The workhorses are the scalable RDCs, the regional data centers. They do all the work. And the most important thing that I want to get across to you about that is that's where all the customer data exists. And that's very, very important, especially due to various country regulations where your data is not allowed to leave the country. So, for example, that's why we have one in Frankfurt, Germany, because in Germany, data is just not allowed to leave the country. Period. It's just the way it is. That is very big. The good news is for any vendor that has what is known as a third generation cloud, you can scale this up fast. we can scale up one of these data centers on either AWS or Google infrastructure in about 30 minutes. Some of the older or earlier people that are in like a first or second generation cloud or a proprietary cloud, they can scale it, but it might actually take them 30 days to spin up one of those data centers. Just to show you the amount of data and the things that goes on in one of these medium-sized regional data centers in a cloud infrastructure, you have like 35K cloud accounts, 8K configuration pushes, 300 million, and this is in one day, 300 million networking events. And I'm not going to go over all of this, but I just kind of want to give you the idea of the kind of things that go on. Of course, any good cloud management solution or application is fully API driven, okay? And a big part of cloud, and when you move into third generation and fourth generation cloud, is what is called the 11 nines of data durability, meaning that your data is always going to be secure, durable, available, and uptime. Any good cloud provider, cloud application should also be agnostic, meaning that you're just not going to be on AWS. AWS might be the market leader, but some verticals just absolutely do not want you to be on AWS. And the perfect example would be retailers. Retailers don't like Amazon, and there's a reason for that, because they're direct competitors. So typically, retailers, if they're going to be using some sort of cloud application, it's probably running on Google. All right, so just a few more things about cloud, and then we're going to move it into the client capabilities, and we'll try to tie some of this together. But I want you to know that the amount of data that we are currently pumping through the cloud right now, and this was prior to the Extreme acquisition, is 1 terabyte of data per second. That's a lot of data, and I fully expect, as a lot of Extreme customers come on, for that to triple, and triple within probably as early as a year. So one of the things people ask me all the time is like, well, how fast is that data and actually gets up to the cloud, and what kind of data goes up? Well, basically anything the access point sees, or it could be a switch or a router, whatever kind of networking device or IoT device that you want to have talk to the cloud, whatever it sees and whatever it's capable of. So when a client associates to an AP, for example, that's pretty instantaneous. That information goes straight up to the cloud like that. Or if a client roams, or if there's a channel change. We actually saw this in the first presentation when we were doing the DFS, and we saw the DFS channels change. We saw it update in the cloud pretty instantaneously. Now, not everything is instantaneous, because if you sent up all information that was collected on every single frame and packet instantaneously, those numbers of terabyte data per second would be like 100-fold. Now, so what we actually do is we look at every single packet and every single frame of every wireless client that passes through an AP, and we look at the radio tap headers, we look at the layer 2 information. We have firewalls in here, so we do deep packet inspection. So we look at from layers 1 through 7, but we don't send all that information up on every single millisecond or microsecond. We put it in buckets and send that information up in 10-minute buckets. As I said, important instantaneous things, like when clients roam, for example, or get associated, that goes up immediately. But information on every single packet finds its way up there, but it's sent up, stored in buckets on the AP and set up in 10-minute intervals. You also get 30-day data retention. And what you're looking at right here is our Client 360 view, and I'm going to segue into clients in just a minute. But once again, we take that 1 terabyte of data per second, and it's processed in the cloud. And a lot of machine learning that you hear that buzzword about so much, a lot of that is things that you don't necessarily see. It's back-end stuff that's being processed, and then that allows us a way to visualize this kind of client information. That way you have both real-time visibility of what the clients are doing as well as historical. One advantage of having a microservices-based third-generation cloud is if it's based on microservices, is you can take the application and put it into separate containers, basically. And what this allows you to do is just update certain portions of that application very fast. So it provides for innovation that I've never seen before. The innovation, once you get to a certain level in cloud capabilities, is extremely fast. So when I'm going to log into Extreme Cloud IQ in just a couple more slides is I'm going to show you Client 360 view, but it wasn't even here 9 months ago. Everything gets innovated and developed in phases, and you can actually see this with this animation. I'm just showing you a couple of phases of how this one particular view has gone. I've just shown you 3 different views of this particular view called Client 360. 9 months ago, it wasn't even here. It's gone through about 9 phases, but that is innovated and changes on the fly without any effect to the customer's wireless network. So let's start talking about clients. One of the advantages of having a cloud is that you can gather a lot of information about clients that are connecting to your network. So we all live in a 2x2 client world, right?
There's a material.
Or do we? Do we live in a 2x2 world? Or do we? So it's happy puppy time again. Let's go look at some maximum client capabilities in the cloud. So give me 1 second here. I'll grow that. All right, so we're going to look at a view here called Client Health View. And once again, we can look at it at a timeline type view. And we're going to look at a month's worth of data. And this is actually, what I'm showing you is actually in our regional data center in Virginia. So the update, well, there's a little bit of latency because it's in Virginia as opposed to the one in Frankfurt. And now we're looking at 30 days worth of information for clients. And we have different views about what's actually going on with the clients, but we also have something called maximum client capabilities. And what we do is we simply look at the probe request and the association request that are being sent up by all clients to the APs, and then we can start visualizing the capabilities of the clients. And we found some interesting things so far, and by the way, this is just the beginning. This has already gone through several phases, and it's going to go through more phases, and I'll talk about that in a minute. Now, there's different views. There's views based on both association request and probe requests from clients that eventually get associated. Not probe requests from clients that never get associated. So just clients that eventually get associated. So you can look at it from information gathered from both or from one to the other. And I'm going to come back to that because you're going to see there are some differences there. And of course, you also have a view of both frequency bands or each band one at a time. So let's just look at 2.4 first. So this is actually at our headquarters, and I can hover over the channels right here, and I can see during this 30-day timeline period that I chose, I could have chose a different slice of time, but I chose a 30-day timeline. I can see that on all these channels, I have 175 devices at our headquarters on 2.4 gigahertz. A month ago, that was about twice as big, but after the acquisition, there's not as many there's some Aerohive employees that have gone elsewhere. But you can see on all channels 1 through 11, you can see 175 capable clients. But you'll notice right here, when we get to channels 12 and 13, those numbers drop, and into 14, there's basically none. I think the FCC actually opened up channels 12 and 13 in the United States a few years ago, but nobody's using them. And you can also see right here that the bulk of the clients have 20 megahertz capability, but there are a few that support 40 megahertz. Hopefully you're not doing that in the 2.4 band, okay? Now, let's take a look at 5 gigahertz.
Channel side, that's where they're on all the channels?
No. This is just saying that they're capable of transmitting on each channel. So right here, this is a view of their capabilities. And in a minute, we're going to compare that to what they're actually doing. Let's take a look at 5 gigahertz. Same thing. If you look at 5 gigahertz, you can see that we have basically, through all the channels, 221 devices that all these clients can transmit on any of these channels. But then we found right here on channel 144 that there's only 208, meaning that there's some older legacy devices that just don't support channel 144. So what you could do based on this information, if that was going to be a concern, you could just eliminate channel 144 from your channel plan. Now, the cool thing about being able to gather information about your client's capabilities is that you can also then compare it to what is actually happening. So you're seeing that the clients support all these channels, but then you can see over that same 30-day period on how they were distributed in our enterprise deployed network. So based on information that you learn about the capabilities compared to how they're actually being distributed, that's where you can start doing creative things on the back end with machine learning and things like that, where you might be able to start tweaking your RRM algorithms, for example. Okay? Now, here's where, and it gets even more interesting. So let's take a look at this. This is back to the client capabilities. You're seeing their maximum transmit power. Okay? We have 11 clients that can transmit at 26 dBm. 2 that can transmit at 30 dBm clients. Now, somebody tell me what 30 dBm is. 1 watt. How many clients do you know that can transmit at 1 watt? Okay? So truth be told, when we first implemented this, we saw the number a lot higher. Now, have you ever heard the phrase that packets don't lie? Anybody ever heard that phrase before? And we actually know that packets can lie if they're corrupted. If they're corrupted, they can lie. But if they're not corrupted, packets don't lie. Okay? But here, guess what? Clients lie. Clients will lie about their capabilities, and this is what we have found out. We found, especially in a lot of Apple devices, that they will actually say that their maximum transmit power is a lot greater than it actually is. And you'll see differences it depends also in the drivers as well. So what we actually did, based on all the information that we had gathered over a couple of months, we basically just decided that we had to start zeroing out some of that information because we just knew it wasn't true, so that we could get a more accurate view of what their actual maximum transmit capabilities are. Now, that being said, you see that some are still popping in there, but as we learn more over time, we'll then try to verify if that's actually true or not. But let's hope there's not real, phones or anything that can transmit at a watt. That would not be a happy day. Okay? So bottom line is, what I'm getting at is the information that comes from clients might not always be accurate, and it might vary from driver to driver. Here's another one. We're looking at 5 gigahertz, right? And we see AC. And we can also go to AX, and if I click on AX, you'll actually see that I have some AX clients in the office there. And once again, there's a little bit of latency here. But you can see it looks like they're all Samsung phones, right? So I'm going to go back to that view. And give me 1 second. Oops, sorry. I want to show you about another lie. I can't show you it, but I'll tell you that. You can see right here, if I go just to the 5 gigahertz view, we see a few AXs, we see like a teeny bit of AXs, but mostly AC devices, right? You know what we were seeing? In 5 gigahertz, we were seeing 802.11b. MacBook Pros. MacBook Pros, not all of them, but some certain versions of drivers were telling us in their probe request frames that they were 802.11b. Okay? So what I'm getting at is that client SLI. Now, they also use, basically, now think about, how does a client and AP even talk to each other? How do they tell each other about their capabilities? Well, the initial way is APs tell them in their beacon frames and their probe responses. They're just saying out to the clients, this is what I can do. I'm an AP and this is what I can do. And the initial way a client tells an AP about its capabilities is in the probe request, right? So let's take that view right here and let's just look at probe request. So if you look at probe request right here, you see that none of them support WMM. What? They're saying, we don't support WMM. And the reason is they don't report that information until they go up in the association request. And then you can see that right there. So if they actually get to the point where they decide, where the AP and the client decide to have a party, at layer 2, I guess, the client decides to get associated, sends the association request, and the association request, think of that as a way for the client to say, okay, yep, I want to party with you, Mr. AP. Here's all my real capabilities and what I'm capable of. So the client may not necessarily expose a lot of its capabilities initially in the probe request, but will definitely show you that in the association requests. And you can see right there, we have almost all clients today support WMM. It's rare that you will not. I mean, WMM has been in place since 2006, okay, and is required for all clients. Now, other things that I want you to point out too is this as well. If we click on both the probe and the associated request, let's look at and we're in 5 gig. Well, let's actually go to 2.4 gigahertz. Well, no multi-user MIMO clients in 2.4, thank God. Now let's go back to 5. And it's saying, for both looking at probe request and association request, it's saying we got about 85 clients that support multi-user MIMO. But if we actually just go to association requests, the number's actually much lower. So they actually, for whatever reason, some clients, I'm not really sure why that number is different between the probes and the association requests, but the main point I want to make is look at the number of multi-user MIMO clients. It's less than 5%. And 5%. Now that number is going to change, because 802.11ax Wi-Fi 6 requires downlink multi-user MIMO, but downlink multi-user MIMO is something I just don't get excited about indoors, because it basically takes the planets to align for it to work. But bottom line is, this is a way that when I can always show customers or people that multi-user MIMO, yeah, even if it did work, the client capabilities just aren't there yet. Now, okay, I got 5 minutes. So, a few more things. You'll note that some of these things are grayed out. So, in the future, we're going to try to give you visibility. Do the clients support Hotspot 2.0? Do they support TPC? Do they support 802.11r? Do they support 802.11v? And I'm going to have that eventually in this view, but I don't have it here now. Does anybody know why those views aren't here? Why I can't show them to you yet? The reason is that information is not available in the probe request and definitely not available in the association request unless those features are turned on the access point. Okay? If those features are turned on the access point, then I can find out in the association request that a client supports 802.11r. If they're not turned on, I won't know. So so that's a problem. And this was actually brought up at WLAN Pros in Phoenix, where some people figured out that they could take the WLAN Pi and they could, was it you, Nigel? Okay, all right, and broadcast out a fake beacon with looking like the AP had everything turned on, And then the clients, when they would send their association request, would basically respond based on that fake beacon and say, yeah, I support R, I support V, I can do Hotspot 2.0. And you could gather more information from clients. So the good news is you guys already have a way of doing that. But how are we going to do that in the cloud? How are we going to do that? So, I'm not promising anything yet, but I've actually got a feature request in, and this is that I want to kind of build that kind of capability into our solution as well. Maybe some sort of hotspot fake beacon feature that you could turn on, kind of like a honeypot that you could turn on temporarily to kind of gather that information. And I'm hoping to have that soon. Okay, and so thank you for that, because I completely stole that from you. So, which I'm not above doing. Now, I have 2 minutes left, so I want to kind of wrap it up with, since we're talking about client capabilities, and show you that, let's take a look at spatial streams. So let's look at 5 gigahertz again. And once again, we see that we have about 151 clients that are 2 by 2 by 2, 57 are 3 by 3 by 3, and a few are 1 by 1 by 1. Okay, so that's about what? About 65, 70% are 2 by 2. But let's take a look at something. That's their capabilities. Up here is their operational functionality. Look how that dropped. See that right there? Look at the numbers for 3 by 3 by 3. We saw that about 25% were 3 by 3 by 3s, but operationally, during this 3-day period, what are they? They're not 3 by 3 by 3s. They've dropped down to here or here, meaning that due to the RF conditions and due to the positioning where the clients are and what technology they're using, they may not always use all 3 radio chains. So you can actually see that a good portion of the 2 by 2 by 2s, a lot of times, are just communicating with one radio chain, or functional as a 1 by 1 by 1. Same thing with the 3 by 3 by 3s. They're downgrading in a lot of cases. And if you look at this at 2.4, let's do the same thing here. I thought, now this is their capabilities, I thought that 1 by 1 by 1 would be a lot higher at 2.4, but we are an enterprise vendor. I think if you went in other customers, I think you'd see a lot more 1 by 1 onlys. But once again, I want to show you in the 2.4, we have a high number of 2 by 2 by 2s, and a little bit of 3 by 3 by 3s, but the 1 by 1 by 1 capabilities go even, you see it even more at the 2.4 because it's a noisier band, okay? That's it. Thanks very much. Oh, one more thing. Sorry. You've heard me evangelizing quite a bit about Wi-Fi 6 for the last year and a half, and this was an AX for Dummies booklet that was available for free, still is. Just want you to know, in about 6 weeks, check at the Extreme website and you will see Wi-Fi 6 for Dummies, okay? And it'll be updated and about twice as big. Thanks very much.